Quantum technology, it's the next big thing, right? I mean, it's set to change practically everything, from medicine to national security, and you better believe there's a huge global race to get there first. So today, we're going to dig into India's master plan, their blueprint for becoming a true quantum superpower.
Which really brings us to the central question, doesn't it? How do you build a quantum superpower from scratch? It's not just about one genius in a lab having a eureka moment. No way. This requires a massive, coordinated national effort.
All right, so to really get a grip on India's strategy, we're going to look at it in three simple parts. First up, we'll check out the big picture, the grand plan itself. Then, we'll dive into the three core pillars that are holding it all up. And finally, we'll see how this stuff actually goes from a laboratory into the real world. Okay, let's jump right in with that grand plan. The heart of it all, the absolute centerpiece of India's strategy, is something called the National Quantum Mission, or NQM for short. And let me tell you, this is not just some vague idea on a whiteboard. It's a huge, government-backed mission. It's the master blueprint for everything we're about to talk about. And you know, the way they've structured the NQM is pretty brilliant. Instead of having one central command telling everyone what to do, they've set up these specialized thematic hubs at the country's best universities. So, for instance, you've got IIT Bombay handling quantum communication, while ISC Bengaluru is tackling quantum materials. It's a smart move, right? It lets the actual experts in each field really take the lead.
And talk about ambition. Just look at this goal. They're aiming to build quantum computers with anywhere from 50 to 1,000 qubits by 2031. Now, if you're not familiar, a qubit is kind of like the superpowered, almost magical version of a regular computer bit. And building a stable machine with that many? That is one of the biggest challenges in science today. So yeah, this is a seriously bold target.
Okay, so you've got this incredible, ambitious plan, but a plan is just a piece of paper without a solid foundation, right? So how do you actually make it all work? Well, that leads us right into our next section, the three core pillars that are building India's quantum future. And these pillars aren't separate things. They're all deeply connected. It all kicks off with academic research, which then fuels industry innovation. And what powers that whole engine? A highly skilled workforce. You need all three working together. So let's take a look at each one. Pillar number one is academia. And this makes total sense. Think about it. The internet, AI, almost every huge tech revolution we've ever seen started in a university lab. So right now, India's top institutes are doing the really deep, fundamental research. This is the kind of stuff that doesn't grab headlines today, but it's the bedrock that everything else will be built on tomorrow. But you know, brilliant ideas in a lab are one thing. You need industry to take those ideas and turn them into actual products. That's pillar number two. And India's private sector is really starting to step up to the plate. We're already seeing startups like QPAI creating real hardware like their 64-qubit processor, Kaveri. That is a massive deal, a really huge milestone. And that brings us to the third and maybe the most critical pillar of all, people. Because you can have the best plans and the coolest tech, but without the brains to make it all happen, you've got nothing. And this is where India has gone all in. Get this, they've trained over 91,000 graduates specifically in quantum tech. That's not just a statistic, that's an army of quantum experts.
And to put that number in perspective, this incredible focus on training has made India number 2 in the entire world for quantum-skilled graduates. That's huge! What they're doing is building the human infrastructure at the exact same time they're building the physical tech. It's a really smart, parallel approach.
All right, so we have the grand plan, and we have the three pillars supporting it. Now for the most important part, from lab to life. How does all this theory and planning actually show up in the real world? Let's see how this blueprint is being put into action. See, the end game here isn't just about doing cool science for its own sake. The ultimate goal is to create a fully quantum-powered economy. We're talking about the government actively pushing this technology into the most critical parts of society: defense, finance, healthcare, communications, to solve some really big real-world problems. This means the entire point of the strategy is to shift away from just doing experiments in a lab and get it out into the real world, into early commercial use. And it's already happening. They're rolling out things like quantum key distribution, QKD for short, which basically uses the laws of physics to create communication channels that are impossible to hack. And also quantum random number generators, which are essential for next-level cybersecurity. This is stuff that's being used right now. So when you step back and look at the whole picture, it's not just one single thing. It's this incredibly comprehensive framework where everything works together.
You've got the big national mission setting the vision. You've got the academic hubs doing the deep research. You have industry and startups building the products. You have this massive pool of skilled people. You have clear government policies, and it all leads to real-world applications. It's a complete top-to-bottom strategy.
So there you have it. India has drawn up this meticulous, comprehensive blueprint to build a quantum superpower literally from the ground up. And they're not just planning it, they are doing it. So, it really leaves us with one big question. In this incredibly high-stakes global race for quantum dominance, is this the blueprint that's finally going to position them to win?